Hello everyone. In this video, I'm going to talk about Kafka. Kafka is a distributed event streaming platform where you can manage the clusters, the brokers, which are the servers, and also the partitions for utmost scalability and throughput, and also parallelism. One cluster, you could have multiple clusters for your setup based on your needs. And in each cluster, you could have one or more brokers which store the data, and you could have partitions where one topic can have one or more partitions to provide that scalability and parallelism. I have a simple diagram where I'm assuming there is one broker in a cluster. In reality, there could be multiple clusters and multiple brokers in each cluster. So let's walk through how it works. You have a producer, it could be one or more producers publishing message to a topic. And one topic could have one or more partitions, and every message that is published will will be sent to one of the four partitions. Not all, just one of the four partitions. And on the consumer side, you can have multiple consumer groups where one consumer group represents one business process that is interested in consuming messages produced by the producer. So in this example, I have two consumer groups, consumer group 1 and 2. And in consumer group 1, I have two consumer processes. And in the second group, I have just one. And each consumer process within a consumer group can read messages from one or more partitions. So in this example, I have consumer 1, which is reading messages from partition P0 and P1, and consumer 2 reading messages from P2 and P3. And if you look at the second consumer group, all the messages from all the partitions are read by only one consumer process. So it just depends on your need and what kind of processing your business consumers need. Once a message is read by a consumer and it is processed, they usually send a commit. They commit the offset back to the broker. And the broker saves those offset commits per partition, per topic, and per consumer group. That is how it can be used once the consumer comes back up after a downtime. So the offset is representing how far each consumer group for a given partition has read until. And let's look at the delivery mechanisms. Delivery in Kafka is strictly consumer driven and it's pull based. So each consumer decides when to read the messages and what to commit. So they have full control on the pace and processing of the messages. Coming to retention, retention is based on either the storage size and or the number of days you want to retain those messages in. So even after a consumer successfully reads and processes the message and commits the offset, the message still stays on the partitions. It is stored. It is stored until the messages until the message retention is valid. And because these messages are stored until the retention period until the retention period is valid, consumers can anytime rewind the offset and replay the messages that they want to process again for any reason. So that's how retries are handled. So the retries are also fully driven by the consumers. The broker does not have to do anything. And there are few other features that I want to talk about. Delivery is at least once by default, and exactly once is optional, but it's possible. So, how does that happen? If the consumer is committing the offset before the message is processed, then it is exactly once. But if the commit happens after the consumer has processed the message, it is possible that that same message could be read more than once. So the delivery is at least once in that scenario. There is no schema there is no schema validation by default provided by the broker. And it is possible to implement schema registry to enforce the schemas by using external tooling. Another feature, because because Kafka stores the messages in the partitions for until the message retention is valid, the consumer can be added, a new consumer group can be added for the same topic even after the messages are published, because they can just start from offset 0. And there's no broker level message filtering as well. Message filtering is usually a consumer responsibility. That's how it's usually implemented, where the message is read by the consumer, they inspect it, and if it's not something that they want to process, they can just ignore the message. And another way message filtering is implemented is you design the topics accordingly. Let's say producer 1 is publishing order events, and instead of publishing all the order events, for example, order placed, order is shipped, order is delivered, instead of publishing all three different events to the same topic, you could design to publish each event to a different topic. So instead of having one topic, you could have three topics. First one could be for order shipped events, second one could be order delivered events, and the third one could be order placed events. And if you have one consumer group only interested in consuming messages for order placed, then they could only listen to messages from that order placed topic. So that's another way message filtering is implemented in Kafka. So Kafka provides this detailed control, more control on how you manage your clusters, brokers, and partitions to provide that full capabilities for enterprises. Thank you.